A physical breach of the skin allows bacteria to bypass the body's outer mechanical barriers. Once inside, they find a warm, nutrient-rich environment and immediately begin to divide. Left unchecked, a single bacterium can multiply into millions in a matter of hours, pouring into the surrounding tissue. The body's first line of defense is the innate immune system. This is a pre-configured generic defense protocol that monitors tissues and reacts to the presence of foreign invaders the moment they arrive. Because bacterial replication is exponential, the host cannot afford to wait for a tailored response. Giving the bacteria even a few days to multiply would allow them to consume the local tissue and spread to the bloodstream. Survival in these opening seconds demands blunt, immediate violence over strategic precision. The innate system deploys heavy local forces to stem the tide. Enter the macrophage. These large white blood cells act as the biological tanks of the immune system. They destroy pathogens through phagocytosis, literally engulfing the bacteria, dragging them inside an internal vesicle, and dissolving them with acid and digestive enzymes. But macrophages operate on a physical limit. As the rapidly multiplying bacteria swarm the battlefield, the few patrolling macrophages quickly run out of capacity to ingest them. Once outnumbered, macrophages release chemical signals to summon reinforcements. This triggers the arrival of neutrophils, highly abundant, short-lived immune cells that flood out of the blood vessels and swarm the localized infection site. Neutrophils do not intend to survive the encounter. When the enemy volume is too high, they violently rip themselves apart. This terminal action casts out a web of DNA and toxic chemicals that traps and disintegrates the bacteria caught in the blast radius. This suicidal attrition slows the enemy advance, but the highly toxic chemicals cause massive collateral damage to the surrounding healthy tissue. A war of raw destruction cannot be sustained indefinitely. When frontline attrition fails to clear the breach, the immune system triggers a tactical shift. It moves away from broad destruction and prepares for targeted assassination. This shift relies on a specialized intelligence officer called a dendritic cell. Its role is to analyze the wreckage of the battlefield. The dendritic cell approaches a destroyed bacterium, breaks it down, and rips a specific molecular fragment off the enemy's corpse. This extracted fragment is an antigen. It serves as a highly specific structural fingerprint that uniquely identifies the invading bacteria. Capturing this antigen upgrades the defense strategy. The body shifts its resources from localized combat to a systemic intelligence operation. The dendritic cell wears this extracted antigen on its outer membrane, physically displaying the enemy data on its hull. It then retreats from the infection, enters the lymphatic vessels, and moves rapidly down these dedicated biological supply lines. Its destination is the nearest lymph node. This functions as an isolated biological command center, located safely away from the frontline destruction. Inside this dark architecture float billions of dormant T cells. These are specialized heavy weapons, held in suspended animation until they receive activation orders. This physical transit of data represents a vulnerable bottleneck in human survival. If the dendritic cell dies on the journey, the intelligence is lost, and the heavy weapons will never wake up. Once inside the command center, the dendritic cell begins the exhaustive task of interfacing with the dormant T cells, one by one. In this diagram, the interface is purely structural. The jagged green antigen tests against unique T cell receptors, searching for a match that slots perfectly into place. Upon connection, the matched T cell awakens and rapidly duplicates through clonal expansion, building an army targeting that specific antigen. This newly formed clone army is the activation of the adaptive immune system. It takes significant time to calculate, but provides a highly specific countermeasure. The days spent suffering a fever, deep fatigue, and physical pain are the biological cost of time. You are feeling the waiting period required to find this precise structural match. The clone army immediately begins manufacturing specialized biological munitions and deploying them directly back to the front lines. Looking at the schematic, we see these munitions, antibodies. They are Y-shaped proteins specifically shaped to bind to the unique contours of the bacterial antigen. Millions of these antibodies arrive at the original breach site, raining down on the battlefield and saturating the remaining bacteria. The antibodies physically snap onto the bacteria. they instantly short-circuit their mechanical movements, neutralizing the threat without detonating the toxins or damaging human tissue. Now covered in these glowing antibodies, the paralyzed bacteria act as marked targets. The heavy macrophages are summoned back into the tissue to safely consume and clear the disabled wreckage. Ultimate survival does not rely on an endless supply of physical endurance. It relies on this autonomous escalation, shifting from brute force trauma to precise biochemical warfare.